We are taking notes on part 2 of equations with two variables. So we're starting with lesson 7.1 today, which is a little bit of a review. If you have your new note packet, please open to lesson 7.1, equation solution types. If you don't have a note packet, you're taking these notes in your learning log. So you would get the title written and then the learning target. I can decide what type of solution there is for a system of equations. Remember, at any time, if you need to pause or rewind, please do so. All right, our first question. What are systems of equations? Systems of equations are two or more linear equations that share two variables. So we've been working with linear equations, and linear equations are equations that make a line. The most common form that we looked at was slope-intercept form, where we had equations that said y equals something like 3x minus 1. From that, we could get the slope, which is 3 over 1. The slope is your m right here, 3 over 1. And the y-intercept is your b, negative 1. We could plot that point and use the slope to build the line. A system is two of these equations. So we could have another one, y equals 7x minus 14, where we have a different slope, a different y-intercept. But the idea is these are a system because they share two variables, and the two variables that they share are your x and your y. That makes a system. Now, we had talked about this second question a while ago, so I just want to remind you that there are three types of solutions that we can get from equations. We can get one solution where the equations would have different slopes. Only one ordered pair makes the system true. So there's one point of intersection where these lines cross, and they are intersecting lines. Get these 3 points written down in the one solution column of this chart. And hopefully it's starting to come back to you now. Oh yes, intersecting lines. What do intersecting lines look like? You have a line going one way, and then you can have another line coming another way, increasing, decreasing lines. And that point where they cross, that's your one point of intersection for the two lines. That's your one solution. Now, the big key here for one solution is that they have different slopes. So if you see that they have different slopes, you know you're going to be looking at a one solution. So for example, if I had a system that looked like this, y equals negative 2x plus 1, and y equals 3x minus 1 from above. Okay, if you look at their slopes, where m is, remember, slope-intercept form, maybe we need to write that on the side here, y equals mx plus b. M is your slope, right? So you look at that slope. In the first one, it's negative 2, so that line would be decreasing. And in the second equation, it's positive 3, so that line would be increasing. So one's going to be getting higher from left to right, one's going to be getting lower from left to right, and at some point, one ordered pair, they will cross and they share. That's their one solution. All right, the second type we can have is no solution. For no solution, the linear equations in the system have the same slope, but they have different y-intercepts, different b's. Okay, so if we come back over here to our side, remember b is your y-intercept. And we write our y-intercept as an ordered pair. 0 is x, and then whatever b is goes in for y in that ordered pair. These are parallel lines. And if you remember, we talked about parallel lines never cross. They run the same direction, like your railroad tracks, right? So an example you would see if you had a system, if you had two linear equations, maybe y equals 3x and y equals 3x plus 1. Same slope. Okay, so let's look here. Same slope. M is the same. M is 3 in both. Different y-intercepts. In the first one, we don't see anything being added or subtracted, so the y-intercept would actually be 0. 0, comma 0. The second one, b is positive 1, so the y-intercept would be 0, comma 1. So one of the lines crosses the y-axis at 0 at the origin, and the other one crosses at positive 1. All right, and then our third solution type were infinite solutions. We also refer to that as many solutions, so I'm going to write that in here. Infinite or many solutions. The description of these kind of lines in this system, they have the same slope. They have the same y-intercept. Many ordered pairs make this system true because they are the same line. So you have a line made from one equation, and then you have the same line made from another equation. So let's say in our system, we have y equals 3x plus 2. And then we have 2y equals 6x plus 4. Now, in this system, one of the linear equations is already in slope-intercept form, and that's what we need to be looking at. The second one is not, because that y has a coefficient of 2. So we would need to convert that second equation to slope-intercept form by dividing both sides by that coefficient of 2. When we do that, then we get y equals 3x plus 2 for our second equation. And now you can see, hey, these are the same line. These are the exact same equation. Same slope, 3 over 1. Same y-intercept, 0 over 2. All right, we're going to take a pause there, and we'll come back for part 2 of this, where we look at some systems and decide what kinds of solutions they are showing.